Hello guys, welcome back to another AIME problem solution video. Today we give you another question here, and as always, let's start off by first reading the question. So, 5 towns are connected by a system of roads. There's exactly one road connecting each pair of towns. Find the number of ways there are to make all the roads one way in such a way that it is possible to get from any town to any other town using the roads, possibly passing through other towns on the way. Now, to first start off this, we need to find out how many total roads there are. So, in total, there should be 5 choose 2 roads, right? After we have 5 towns, and we need to pick 2 or like a pair, and that's how many roads there should be. So in other words, the total number of configurations should be 2 to the power of this number. Now, luckily, 5 choose 2 is equal to 10, so I can write this out right here, like so. Which means that this is our total number of configurations of towns with roads next to each pair. Now, currently, the best way to solve this problem would most likely be to find how many configurations don't work, and then subtract that from our total to find the number of configurations that do work. Now, to find the number of bad configurations, we're going to have to do some casework. So our first case is that for one of the towns, all the roads are going into it. So they all go into this one town. So I'm going to write a small graph here. Let's write in a sort of like die shape, like so. Now, our first case is if all the roads lead into one town. This means that when you're in this town, you can't really escape it, and this would be a bad configuration. So this is going to be our first case. Now, in this case, we know there's a total of 10 roads, and there are 5 ways to choose one of the towns. So 5 times another number. Now, what is this other number? Well, because we have the 4 roads leading into this one town, we know that there should be still 10 minus 4, or 6 different roads. Now, there are different ways to assign this road, so there should be another 2 to the power of 6 roads. There should be another 2 to the power of 6 ways that we can rearrange the other 6 roads. Now, our second case is the exact opposite of this one, where instead of all the roads lead into this one point, all the roads lead out of this point, like so. So instead of being it like this, it's going to be reversed, like so. Now, obviously, I haven't drawn the rest of the roads for this because that would take way too long. But for simplicity's sake, you can see here that as you can see before, similarly to this one, there's going to be one town, and all 4 of its roads are going to be leading out. Now, in this case, it's going to be similar to this one. There are 5 ways to pick the town, and for the other 6 roads, there are 2 to the power of 6 different configurations. Now, here it seems pretty clear cut that the number of bad configurations should be 5 times 2 to the power of 6 times 2, because we have 2 of these. However, we've actually overcounted, as there's another special case where we have one town that has everything leading out to it, and one town that has everything going into it in one configuration. Now, how many ways are there to do this? Well, it is also pretty simple. So this is going to be our third case, the one where we've overcounted. Now, in this case, we have, as I said before, 5 ways to pick the first town times 4. And why is this? Well, similarly to this one, we have 5 ways to pick the first town and 4 ways to pick the second town that is special. Now, from this, we're using 7 roads for this thing. So this means that we're left with around 3 roads. So this means that we have to multiply this by 2 to the power of 3, as there are 3 roads left, and this is the total number of configurations that we can configure these 3 roads that are left. Now we can calculate how many there are. Now we can calculate the number of good combinations that we have. So since we have all the bad combinations here, our answer should be pretty clear cut. It should be the total number, so 2 to the power of 10 minus 5 times 2 to the power of 6 minus 5 times 2 to the power of 6, and then we need to add back 5 times, oh, I forgot to write 2 to the power of 6 here, 5 times 4 times 2 to the power of 3, as this is the case where we've actually overcounted in these two, so we need to add it back. And this, after some quick solving, our answer should be 544. So the answer to this problem should be 544. Thank you guys for listening. If you have any other way to solve this problem, please let me know down below in the comments, and thank you guys for listening. Bye.